Then I would ask Sören to give his talk.
Thanks, Lars, for the introduction. Thank you all for joining. I hope you can see my presentation now. So I would like to introduce a bit to you why we are working on the Open Research Knowledge Graph and why this is so important to contribute. So if we look at how information flows changed in different areas, you see here some examples. Yeah, so on the left, you have mail order catalogs, 20, 30 years. This was extremely popular to order products and to buy things using these mail order catalogs, or street maps. In order to navigate from A to B, you had to buy maps and to use those maps for navigation, phone books, encyclopedias, and I guess you can name many more of these examples. And these completely changed, these information flows in the digital era in these different domains. Whole industries got disrupted. And we now use digital tools like Amazon, eBay, or in Germany, Dialo. We use Google Maps or OpenStreetMaps for navigation or navigation systems. We use Wikipedia. And these are not just analog copies or digital copies of the analog versions. So this is not just a PDF scan of a mail order catalog or a PDF scan of a street map or of an encyclopedia, but these are digital-born services which allow that we can zoom into the data, that we can filter. There's much more dynamics. The business models also changed. There are completely new companies appearing there. There's more focus on data, interlinking data, search in the data. Also, crowdsourcing and data curation plays an important role. And I guess many of you have contributed to creating data in these platforms, sometimes unconsciously. So what about scholarly communication? Because the Open Research Knowledge Graph is about scholarly communication, about publications, scientific papers. And if we look how that evolved over the centuries, it didn't change much, actually. And what we are doing is we just work with the pseudo-digitized versions of the analog artifacts. Of course, we can now exchange articles, scientific articles, as PDF documents over the internet, but that would be comparable to using a scan of a map for navigation. And no one would do that nowadays. So, and this creates a number of problems in science, in research. We have a reproducibility crisis. For example, many experiments are very hard or not reproducible. We have a proliferation of publications. There is a flood of publications. The publication output, for example, doubled within a decade and is continuing to rise. And that makes it also very difficult to peer review these publications properly. So the quality of peer reviews deteriorates. These are some of the fundamental pillars of science: reproducibility, peer review, and my impression is that they currently don't work as they should work. So how can we change that, or what would we like to do? If you look also in other domains, for example, if you want to build an engine or you want to build a building, you need to identify the different parts very clearly to fit them together to a complex engineering artifact like an engine or a building. And I think in research and science, we should build a building of wisdom, right? So the things we describe in papers should fit together. They should be comparable. They should be described so that we can actually really generate new knowledge without drowning in this flood of publications. And the current state also results in the number of deficiencies. So we have a lack of transparency. Information is hidden in texts. We have a lack of integratability. Different pieces don't fit well together. Machine assistance is hard or almost impossible. We can search, we can do keyword search, but we cannot really answer questions or filter in research results. We have a problem of identifiability. Of course, we can identify publications and maybe authors with DOIs and ORCID, but we need to identify actually the concepts described in these papers. And that's why scientists are really often looking for the needle in the haystack. And I want to illustrate that with one example. So this screenshot is already 2 years old, but if you were searching for CRISPR 2 years ago, you found 238,000 results. That's a famous genome editing method. Probably now you find much more than 250,000 results. And if you are then interested, how good is the method with regard to precision, safety, or cost? What specifics does it have when you are applying it to insects, or who has applied it to butterflies? You're completely lost in this flood of publications, and it needs you several years of research to answer these research questions. So how can we fix that? That's, of course, looks a bit depressing, but that's why we want to build the Open Research Knowledge Graph. So a knowledge graph which organizes overarching concepts like research problems, definitions, research approaches, methods, also different artifacts, in addition to publications, also data, software, audio, video, images, in such a knowledge graph. And then, of course, also domain-specific concepts, which vary very much between different domains. In mathematics, you have definitions, theorems, proofs. In physics, experiments, data, and models. In chemistry, substances, structures, reactions, and so on and so forth. And we would like to describe these concepts and link these concepts semantically in the Open Research Knowledge Graph. And this follows also the vision of Tim Berners-Lee. He coined this linked data principles to identify things with your eyes, to make them machine readable, that you can look these up, and that you have a common format like the RDF resource description format. And more recently, also the FAIR data principles became more popular and also follow in this footsteps of this vision. Our idea is that when we have a paper, that a paper is accompanied with some descriptions of the gist of the scientific contributions of the paper. So here we have a paper, a practical guide to CRISPR-Cas9 genome editing in Lepidoptera. And we would like to accompany this paper not only with metadata about the authors and the title, but also with information what research problem is addressed by this paper, what methods are used, what are they applied on, where can I find experimental data, and that requires curation. So we hope you are interested to contribute in the curation, and curation means filling out forms in the Open Research Knowledge Graph, but these forms are just the surface. In the end, actually, we build a knowledge graph, and you see a small snippet on the bottom of this slide here representing this part of information semantically. And as a result, we can then use this knowledge graph to answer questions. And one question would be, how do different genome editing techniques compare? And all of you have probably used services like Amazon Alexa or Google Now, where you can ask questions about the weather, about points of interest, about a TV program. And we would like to be able to also answer questions about research and science. And of course, for that, we need such a knowledge graph, and we can leverage the knowledge graph. And from a knowledge graph, we can then construct formal queries. Here is an example of a Sparkle query, which allows that you don't have to build these queries yourself, but that's the vision later on, that the machine can build such queries for us and render the results to the user. And the result, for example, for comparing genome editing techniques would look like this. So here we have a table with different genome editing techniques and compared with regard to site specificity, safety, ease of use. And we would like to implement that with the Open Research Knowledge Graph. And let me show you maybe some examples in the Open Research Knowledge Graph before we come to the how-to sessions. So one research problem which currently affects us all is the COVID-19 pandemic. And one important research question is, what is the reproductive number for COVID-19? So basically the number of how many people are infected by one infected person. And there are a number of studies. We actually found more than 30 of these studies. And if you take each of these studies individually, you won't find a precise answer, but only by looking at all of these studies, you can get an overview And that's why we added these studies to the Open Research Knowledge Graph. So we added some meta information, but also what is the R0 estimate. You can see that here in the middle in this row. The first study, for example, estimates it to be 4.38, the second one to be 3.41, and so on and so forth. And you also have information about where was the study performed, when was it performed, what methods were used. And in a summary, you can then get an overview of the R0 values from different studies, and you can estimate what probably the R0 estimate is in general by taking, for example, an average or by comparing these studies. If you would want to read all these studies, you would have to read hundreds of pages because each of the studies is 10, 20 pages. Sometimes they also discuss different research problems, not just one. And to figure that out would be very cumbersome and time consuming. We added these studies to the Open Research Knowledge Graph, and here you see one example. We will show you some more later on, and you can basically see the bibliographic metadata on top here, and then you have a description of the contributions made by the study. You also see a link to the DOI, so where you can access the full text, but then we have this property subject predicate value notation to describe the contributions. For example, the 95% confidence interval here in that case is 1.45 to 2.48, and the location of the study is Singapore, and our R0 estimate is 1.97. So the Open Research Knowledge Graph can be curated and edited. Once you logged in, you can actually edit all these values and can add more information. That's what you see here. It's basically a form which is generated, but you can also add additional properties. So it's not fixed form, but it actually allows you to add, depending on the type of contribution you want to add new properties. Allard will show us in a few minutes to you how that works. And as a result, we can really look at the graph. So here we have the bibliographic information from this study, but we can then also look at the contribution, and we can see actually the values of the contribution directly in the graph. And you can see that in the end, we built here a knowledge graph which is interlinked. So all these different contributions are linked with each other semantically. And then we can use this knowledge graph for generating visualizations. And here are some examples of visualizations, which gives you an even more condensed view of the state of the art for a certain research question. And Vitalis Wiens will tell you a bit later how you can build such visualizations. And of course, we organize the knowledge in the Open Research Knowledge Graph in research fields. So you can see here an example of a research field. Here it's virology, but of course we have pages for all kinds of research fields, almost 500. And in these research fields, you then find the research problems, the latest updates, the contributors, also observatories. So these are domain-specific observatories. And then on the bottom, the comparisons, the visualizations, and the papers underlying these comparisons and visualizations. So here you see a page which is generated for a research problem. So from a research field, virology, for example, you can click on the link COVID-19 reproductive number. Then you will see a page describing this particular research problem. So we have also linked Wikipedia here and the summary from there. And then we have the authors which contributed to answer this research question. We have super problems or sub problems, and underneath also the papers which contributed to answering this research problem. Yeah, and these can be organized also in observatories. So this is a way how to organize domain-specific information related to a particular domain, and also acknowledge organizations in these observatories. For example, for COVID-19, we created an observatory which again summarizes the research problems and then also prominently acknowledges the organizations and shows the content like visualizations and comparisons. Also, the organizations who contribute to the ORKG are prominently acknowledged, so you can find all organizations. We are still in an early phase, so there are not yet that many organizations, but we plan to improve that in the next months and in the next years. And of course, this is a long-term development effort, so we plan it's a strategic initiative which we started at TRB, but the whole project is open source, it's open data, everything can be downloaded and access the software, but also the data. And here you see the members of the team where we have PhD students. So Allard and and Vitalis will also present today results of their research, but we have also a software development team there, and we plan to sustain this service in the long term. Yeah, and with this, I would like to conclude my overview on the Open Research Knowledge Graph. Thank you very much for your attention, and I hope we can now zoom into some more details and show you how concretely you can contribute to the ORKG, because we really think that this is an important effort for science and research overall, and it's very important to make research, to lift research and science to the digital age. Thank you very much for your attention so far.
Thank you, Sören, for that great introduction. Just a reminder, we are recording. If you have questions, please post them into the chat and we will answer them either there or after the sessions. So the next talk or presentation will be given by Allard Oelen, who is one of our PhD students and working on the Open Research Knowledge Graph. And he will introduce you into how to create paper entries and surveys, which we call comparisons in the Open Research Knowledge Graph. So the stage is yours, Allard.
Yeah, then I'll start. Indeed, my name is Allard Oelen. I will present today a little how-to on how you can create entries in the ORKG, paper entries, and how you can build comparisons. So a quick agenda of what I will be discussing. So the first thing I'd like to show you, I'd like to start with the end result. So start with showing you what we are going to create today. And then afterwards, I'm going to show you, okay, how is this created? How is this comparison created? And how can you add a single paper to this entry? So Soren Auer already showed comparisons in ORKG, and I will keep using this COVID-19 example as a running example also throughout this presentation. And this is basically the comparison I'd like to create today. You can see 3 columns here. So in each of the columns, a paper is represented. And these papers, they are reporting R0 numbers. So in the rows, we see some additional information like the confidence interval and the location where this number is recorded. So if we have a quick step back, so where is this data actually coming from? So this is an example of a paper. If we then have a look at the abstract, we can already see it contains quite some information. For example, the research problem is mentioned there. The location is mentioned. Here we can also see the R0 estimate. So at the end of the abstract, the results are mentioned. And finally, also the confidence interval. So this information all leads to this comparison object here. So now at least you understand a bit where this data is coming from. And this will then really be a how-to session. So we'll shut down the presentation and then take you to the ORKG to see how this works. So I will do this on my local machine. So you will see not orkg.org, but localhost. So the changes I make will not be published. So I can make mistakes here. So we start with adding a new comparison. So we click the Add New button on top and we click Comparison. Then you will be seeing a page that explains a bit what is a comparison and how to create one. And the first step is that you can import existing data. So if you have existing data, you can structure this and format this in a CSV file. And then you can follow a 3-step process to import this CSV file. This is not what we are doing today. Today we are really starting from scratch. So we're starting with an empty contribution. So we skip step 1 and go directly to step 2, the contribution editor. From here, we can start building the comparison. So we start with adding a contribution by clicking the Add Contribution button there. Normally, you would first look for a paper either by title or by DOI and see if it already exists in the graph. But for now, I will add a new paper anyway. In this view, we can enter the paper's metadata, so we can specify the title, the publication date, the research fields, but also we can collect quite a lot of this information automatically if we enter the paper DOI. So that's what I will be doing now. I'm copy pasting a DOI here and then click Lookup. There's a message that the paper is already in ORKG. Like I said, for now, I'm ignoring that. It's a demonstration, but normally it's better to not add the same paper twice, but just to update the existing paper. But for now, we'll just continue. The only thing we have to do still is to select the research fields. This is a mandatory step here. So we can click Choose, and then we see the full taxonomy of the ORKG. So we can expand items and we can look for the item that is most suitable. You can also use the search bar here. So we are discussing the R0 value of COVID-19. So virology seems to be a suitable field. So we can search virology and then click if it appears. And then you'll see it automatically selects the fields virology and microbiology there. And now we can select it. We have everything we need. So now we can create a paper. And now the paper is added to the table. So a column is added here. And you'll see directly one row is added, has research problem. So we start by specifying the research problem that this paper is addressing. So by double clicking on the cell, we can enter the value. And the research problem we are addressing is in this case the COVID-19 basic reproduction number. So as soon as we start typing, we get recommendations of values that are already in the graph. And here you can see already the COVID-19 basic reproduction number is present, so we can just click this. You also see after clicking it, the data is automatically saved. So everything you'll do is automatically saved. Let's now add the actual R0 number. That's the most interesting value for this paper. So I type R0, and the same here. Automatically, it looks for values that already exist in the graph. And we can click this one. Here we can also see a description of the property. So the expected number of people that an infected person will infect. And now it is added. We can again enter a type or enter the value by double clicking here. And then we have to select the type. So we can either choose a resource or a literal. Since we are adding a number here and this number is not further described, we choose the type literal. And this paper presents a value of 2.56. And that's now added as well. So we continue now with some additional data, for example, the confidence interval. But what if we would want to add a property that does not yet exist? So I type non-existing, for example. Then you'll see there is an option to create it. If we click Create Property, it will ask you to confirm whether you indeed need this property or not, because it's better to reuse existing properties. But of course, it is always possible to create new properties. In this case, for the confidence interval, actually the properties already exist. So here we see the 95% confidence interval upper limit and lower limit. So we are adding them both, the upper and the lower limits. And we are also entering those values. So we have to select a literal here. This is the lower limit and the upper limit as well. Finally, we also, just for completeness, add the location. This study is actually targeting China, so we enter that as a resource. Or in this case, let's make it a literal. Normally, you would use a resource for this example. So this is now we have the data of one contribution. And of course, it becomes interesting once we start adding more contributions here. So I will click Add Contribution, and now I will quickly run through the same steps I just did, but only without explaining. So I will copy a different DOI here, ignore the message that it already exists, select the virology research field, and create the paper. Now it's added here. You'll see because the properties are already added, it's a lot easier now to enter the values for this additional paper. So this is 3.4, 4.2. We have the same research problem. That makes it quite interesting because all those different contributions, they are addressing the same problem, meaning that it's later possible to say, give me all research that addresses this problem, which could be quite powerful in the end, especially if a lot of papers are added. Then we add another location, which is Iran for this paper, and finally the actual R0 estimate. And now you'll see we have a comparison already. To make it an actual comparison and to publish it, we have to click the View Comparison button first. Here you can see the comparison is being generated. And from this view, it's also possible to customize this comparison before publishing it. So we can click on More, and we can click Select Properties. From there, we can determine which properties should be displayed in the comparison and also what the order should be. So in this case, I think it makes sense to say has research problem is the most important property. So we add that to the top. And the R0 value looks nice underneath that. And there we have the confidence interval and the location. Well, once we are done customizing our comparison, we can publish it. So we can click More again and go to Publish. In this view, we are publishing the comparison with additional metadata. So that includes a title, a description, possibly references. So papers we used to create this comparison, the fields and creators. So in this case, I think COVID-19 R0 estimate comparison seems suitable. And here we can write a longer description explaining what our goal is, what we're trying to achieve with this comparison. Finally, it's possible to assign a DOI to the comparison. This makes sure that you can cite the comparison within papers, and it also ensures that the comparison is static and cannot be updated anymore or cannot be changed. It's possible to update but not change the comparison. What that exactly means, I will show later. So now we click Publish, and then you'll see the comparison is published. So now we are looking at a published comparison. Let's say we are using this, but now somebody else wants to add an additional paper to this. This is possible. We could do it using this contribution editor I just showed, but there's also another way to do it. And that is using the so-called Add Paper wizard. So that is a tool specifically focusing on adding an individual paper. So it's a 3-step wizard, and basically you can specify the same kind of data as the contribution editor, but only for a single paper. So I will copy again another DOI here and show you how this process works. So we do a lookup. We see the title, the authors, and the publication date. It's all fetched automatically. We go to the next step where we then have to select again a research field. So again, this is an R0 paper. So virology seems the right field. And the third step is to specify the contribution data. So this is free form. We can add any data we would like. But of course, since our goal is now to add it to the comparison, I will use the same properties as we used before. And I will start with adding a research problem. That's already recommended that it makes sense to add a research problem here. That's what I'll do. So in this case, I will again type COVID-19 basic reproduction number, same problem we had before. And I will add the same data. So I will start with an R0 estimate. I will first add the properties now. Then again, 95% confidence interval, the upper limits, the lower limits, and also the location. So now we have all the properties, and now we can start adding this data again for this specific paper. Again, here we have to select whether it's the literal or the source. We added all our data as literals, so we'll do that. This is 1.27 for this specific paper. Again, a literal 1.19. and the lower, actually, I am making a little mistake there. It's 1.36, and here a literal of 1.19. And finally, the location is Singapore. We created it as a literal. So now we have added this data, and we can basically store this paper as well. And then the next step would be to add this paper to the comparison. So first we can have a look at the paper. This is this overview, this view paper page that Soren Auer also just showed with the data here. And we are adding it to our comparison now. So to find my comparison back, I could use the search bar. I could go to the overview of all comparisons, or I can visit my profile. That's what I'll do now. And at my profile page, I can see the published comparisons. So I can click this comparison, and there it is again. Now I will add a contribution to this comparison by clicking the Add Contribution button. And here I can search for the contribution I just added. I'll do this again by DOI. And I say, okay, this is indeed the paper. That's the same title. And I'm adding it now. Here we now have a comparison with 3 instead of 2 contributions. Finally, I'd like to show you, okay, we did this step. Now we want to publish this as well. So we can publish this again. You'll see the title and the description, they stayed the same. It's possible to update them if we'd like. And more importantly, we can see that the comparison will be marked as a new version of the previous comparison. So there will be a timeline where you can say, okay, this is the current version I'm looking at. So after publishing, it's again published. And we can see here in the history, okay, this is the current version, the newest one we're looking at, and there was a previous version, which only contained 2 comparisons or 2 contributions, actually. I think this is all I have to say about adding papers and comparisons. I think the next thing is that Vitalis will show how you can use those comparisons to make visualizations.
Thank you, Allard. That was a great introduction to how to create paper entries and contributions in the Open Research Knowledge Graph. And next will be Vitalis, who will introduce you into how you can use those contributions to make visualizations with them within the Open Research Knowledge Graph. So Vitalis.
Present. So hello everyone, my name is Vitalis, and today I'm going to talk about visualizations in ORKG. So what we are going to see today is how to visualize content of papers and visualizing also comparisons. So as we've seen before, we have the different contribution data, and we use the statement browser as navigation, and it allows you to explore resources using links, and then you can click on them, and you will receive like breadcrumbs that help you to navigate through the information that is stored in a comparison or in a contribution, sorry. And you can also use the graph view button, which allows you to see directly the graph. And I would like to explain a little bit about the notation that we are using here. So we have a node link diagram where we have different resources, and resources are illustrated as a blue circle. And on this, you can also perform interaction operations like collapse, expand, and also explore. So when you have this magnifying glass, this means that the system has not yet read the data behind this node, and you can click on it and explore it. And if you want to reduce the information, you can press this double arrow to collapse a node. And if you want to expand it, you can press this button. Collapse node is indicated by these 2 additional underneath circles. And this shall help you a little bit to understand and navigate through the data. And we also have literals, and literals are displayed as rectangles with yellow background, and they also have green properties in order to distinguish directly in the visual representation between those. And we can also do a search directly in the graph. When we search, we have autocomplete and also auto-expand, which means basically, for example, the similarity comparison is not visualized in the graph, but when you click on it, it will automatically determine where is the node in the graph and build a link to it and then expand it in such a way. But the search functions only on the dictionary that is currently visible or has been loaded by the graph visualization. And so it can happen that you have not explored certain properties of a certain node, and that's why they are not in the dictionary yet. But using the load full graph and try again, you are able simply to load all the data into the graph and then be able to search within this graph directly. And once you find it, you will have a halo visualization that will indicate location in the graph, and you can press the locate button in order to zoom directly to this particular node. And if there are multiple values that have been found, you can also then traverse between them. And yes, so this was a short introduction with respect to the graph visualization. And now we're coming to the visualization of comparisons. So a prerequisite is here that we have published comparisons. And I want to show a short workflow, how you can also do this in a different way. So basically, when you go to a paper and you have a contribution, you can also select this add contribution, add to comparison checkbox. And this will give you an information box, how many contributions you want to compare. And you need to have at least 2 contributions in order to start the comparison. And basically, when you have selected the information that you want to compare, you can press the Start Comparison button, and this will then create the comparison. And after you have published it, you will have this kind of representation. So you have like the number of contributions within this comparison. You have some meta information about this comparison that you have entered before. You have maybe if there are already visualizations, you will have visualization previews, and then also you have the table. If you don't have this information, you most likely have not published the comparison, and using the more and then publish, you can publish this comparison because we attach the visualizations directly to the comparison node. That's why we need to publish them. And as long as you have not published the comparison, this visualize button will be disabled and you are not allowed to create a visualization. So once we click on this visualize button, we will see this widget, which will create the visualization for this comparison. And here's also a link to the video explaining how to use this in more detail. And we have on top these 3 tabs for the navigation, but you can also use the next button here. And what is the workflow? So basically, we want to select some data, we want to map it, and then we want to visualize it. And for this, in the selection tab, we select columns for the visualization. And here's one note that we display all the columns, even though if they have not been visualized in the previous tab of the comparison, because as we saw before, you can rearrange the order of the properties, but you can also hide them in order simply to reduce some of the information in order not to create a very big table. But as you can see, it tends to become very large, and it is much easier to compare numbers when we have visual representations such as charts. And then we basically, after we have selected data that we are interested in, we map it to specific data types. Currently, we have strings, numbers, and dates. And basically, when we, after the selection, we go to the next tab, and most of the entries will be, all of the entries will be red because we have not yet selected the mapper. And then we select the mapper based on these data types. And if they are validated, they will become green. And then basically we can continue with creating the visualization. And when we create a visualization, this is a preview of the tab where we will have some customization options, and then we will have the preview of the chart visualization. And here we can also, when we are satisfied with our visualization, we can then publish it. So we have different visualization method selections. We have axis selections, and we can also have axis label suggestions. And basically, the publish visualization button creates attaches this visualization to the comparison itself. So with this, I would like to go then to the live demo. And here we see this is a published comparison. We press the visualize button, and I would like simply to use my standard example where we have the location, and we have the R0 value and the lower and the upper confidence values. Then we select, for example, the location as a string at the moment. We would like to extend this later to use geo namespace in order also to be able to have this on a map directly be displayed. And as we can see here, for example, this red values, they are not displayed because they have not been added into the value of the table itself. And then we continue. And this is the first view that we have. And basically, we can also look at our confidence values of our input table. And this is for debugging purposes, more or less. And then we can, for example, select the column chart. And here, what we can additionally do is we have selected multiple columns. And here we can either add them directly as the values. But since we are doing confidence intervals, it's also interesting to have the intervals to add them to a particular column. And with this, we can add intervals directly into the visualization, and then we will have the estimated intervals for this bar chart visualization. And as we can see, has value is not very descriptive. So we can go back to the information here, and what we can do is we can edit the name for the property and say this are R0 estimates. And once we have edited, it will show us in a bold font, and we can also hover over it and also undo this. And for this thing, we can then select the R0 estimates, and then we have the information here. But we can also create here different labels that are directly reflected on the axis. And then when we press the publish button, we can add a title like R0 estimates as column chart. And we can also add creator and so on. And basically, when we press the publish button, please select the title and the description. Okay, it gives us a warning that we should also add the description. The estimates for 0 as column chart. And then using the autocomplete, we can also find ourselves in the authors. And now we can press the publish button. This takes a little bit. And then it adds it automatically to the visualization. And here we see that what it has saved, it has saved all our states. And by clicking on this preview card, you will come to the state which you have previously selected. So it saves all the information that you have entered before. And you can also go to another visualization that we have created previously before in order to see this as a scatter chart. You will see the same information. For example, here is a different property that we have changed in order to provide this in the visualization. And from here, we could also start directly to change the visualization method, for example, as a column chart, which has now the has beginning of the study as a selected date. And from here, you could directly publish a new visualization with minimum effort in order, because somebody else has already selected the correct columns, the correct mappings. And the only thing that you have then now to do is to select the correct axis, assign maybe a different label, and create maybe the intervals. And with this, you can directly create a new derivative of the previously created visualization. With that, I would like to thank you for your attention.
Thank you, Vitalis. So we're through with the sessions, and I would now stop the recording, and then after that we can look at some of the questions that haven't been answered yet.